Peter, you can take the wheel.
Okay, thank you. Well, welcome everybody who's here to the ITSMF 2016 SMEXA running over the next 3 days. I hope you're going to enjoy this, whether you're watching it now or as a recording. Our first speaker today is James. We're looking forward to hearing his presentation on robotics, and I'm going to hand over to him now. Thank you very much.
Excellent. Good morning or good evening, good afternoon, everybody. I'm just going to quick take control of the dashboard and we'll kick off then. Perfect. So, guys, what I want to talk about today is robotic process automation. And if you look at the sort of recent trend around the globe, it's something that's a very pertinent conversation. But before we jump into the detail, I'm going to show a quick little video just to kind of set the scene and get our mind sort of in the right calibration. Excellent. So maybe the starting point here, for some reason seem to have a problem with the next slide. Apologies, looks like it shut down my PowerPoint, but we'll be up in a second. There we go, we seem to be back online. Apologies for that. So basically, in short, guys, welcome to the Fourth Industrial Revolution. The video you just seen now was actually presented at the World Economic Forum, and I like showing it because the World Economic Forum are not renowned for hype and drama. They tend to only talk about things that are really relevant to their market and the environment globally at a point in time. Wow, we're really having problems with this thing now. There we go. Let's try this again. In Davos, they actually announced the advent of the Fourth Industrial Revolution. Now, many people ask me, well, what will be the hallmarks? What are the attributes of that Fourth Industrial Revolution? Well, quite simplistically, it will be remembered for the convergence of technology. So in the last sort of almost 60 years, there's been massive acceleration in all sorts of inventions, being in the medical fraternity, being industrial technology, being IT and hardware, software, regardless of the domain, we've made large progress. But they've always been within their siloed areas. The Fourth Industrial Revolution remembered for the convergence and the bridge between these areas. So how do I do no augmentation along with device meshing, for example? But for many years we've been waiting for something to happen, something to trigger this event, to bring it on. And robotic process automation is one of those technologies which is enabling the commencement of the fourth industrial revolution. Now, many people will ask me, well, what exactly is it? And if I look at it to sort of the far left-hand on the spectrum, we get classic old desktop automation. Things we've known for more than 10, 15 years, R, Python, scripting languages to automate certain key elements of a process. And on the far right-hand side of the spectrum, we have full-blown artificial intelligence. Robotics sits somewhere in between the two of them. But it's very important for you to be able to define what it is and what it is not due to those overlaps. So very simplistically, the way I normally articulate it is as follows. If you have an end-to-end process or value chain or stream, in an ideal world, that process will look something like this. Systems that start at the beginning and run all the way through to the end, tightly integrated, data residing in single domains, very little human intervention, and a very well-controlled, structured environment. In reality, what most of our environments look like is something like this. Huge amounts of human intervention, processes, manual activities that either link across our systems, permeate our value chain from start to finish. Very classic scenario of this would be, for example, your SAP, or could be your ERP system, which is your primary transacting system. But in parallel to that, our communication system is email. So our process would start in the system and run at great computer speeds, then suddenly stop because we need to communicate. Data is removed from the system, stuck into emails, dropped into Excel, moved around the environment, and at some point in time put back into the system. Now, this jumping between the various systems increases the value chain significantly. This requires us to be able to have to put down very complex BI and data management to control the process from end to end. In addition to that, we have complex oversight and management to control the manual interventions of the process. Once again, adding cost, latency, effort to an otherwise, which should simplistically be quite a tight value chain. The focus of RPA is to tackle some of those elements and remove as many of the human interventions that are possibly there through a variety of reasons, and I'll touch on those in a bit more detail. But if for something to be called robotic process automation, it is important that it actually obtains 6 attributes, because in the absence of these attributes, it cannot be either be desktop automation, AI, or hardware combination of these. These 6 attributes also define and also explain what a robot can or cannot do. The first one of these is it must be user interface focused. And in my personal opinion, this is probably the most profound element of robotization. What it basically means is the robot interacts with any environment, application, or system through the front end. So a robot would technically log into an ERP system or a spreadsheet or a computer like I would with a username and a password. It would then interact and act through various screens and notifications in the same way a human would. This ability to be able to go to the front end means that you can deploy robotics in a mass environment without changing a single line of code in your existing IT infrastructure. So you can deploy them very quickly without destabilizing the broader enterprise architecture space. In addition to this, the fact that it logs in through the front end means that control and governance is much tighter, because I can physically see the username and password that has transacted in the system. So you'd see James has done transactions 1, 2, and 3, and Robot 1 has done transactions 7, 8, and 9, which is far better than the old days where we used to have tight integration in the back end, which often meant that transactions appeared in our system, and we're never quite sure where they came from or the lineage that resulted in them appearing. The next attribute is the ability to be able to schedule and monitor your robots. I must be able to tell a robot to wake up at 8 o'clock on Monday morning, do tasks A, B, and C for an hour, at 9 o'clock do tasks X, Y, and Z, and at the whole time monitor an environment or a space or an event looking for something to happen. So, for example, look at an email inbox and wait for an email to land. As soon as the email lands, it must stop its normal activities, process that event or the transaction, and then come back to its routine transacting. So the ability to be both time-based and event-based in its trigger is very important. The third attribute, it must be business user-friendly. You must allow the business to be able to monitor, transact, interact with, code, and deploy the robots very, very quickly. And this is important because if a robot is targeting the processes that somebody in my team would normally do as a human, by inference, it must allow me to be able to control that robot as easily as I would with my people. So if my process changed, I should be able to pull my team together and say, guys, as of tomorrow, this is the new process. Similarly, I must be able to go to the robot and say, tweak the code, and within a couple of hours, be able to have the new process functioning through that robot. Now, in a normal case, I can take a non-technical resource and train them up to do robotic process automation in under 3 weeks. So that means I can scale this very, very easily. So the environment where they are deploying robots is not beholden to the central core IT software development team to be able to manage it. So any organization, regardless of the development capabilities, can robotize, deploy, and scale very, very quickly. The fourth attribute is a full audit history. Now, we all know very well that I can only look at the code of my existing applications as they stand today. I cannot see what the code looked like a week ago or a month ago. And that's why we use complex data analytics to be able to analyze that no one has messed with the systems during the period of review. Not so much the robot. So, for example, if I accessed the robot last week, changed the code for an hour or so, put a few transactions through and changed it back, I cannot mask that. The robot will natively store every instance and history of itself. So it's very easy for us to be able to go back and review what the robot was doing at any point in time since the history of its inception. That gives us a huge amount of governance control that otherwise we don't get from other systems. The fifth element is security, the ability to be able to password protect the robot. So it's not just accessible to anybody if they access our network. We must be able to encrypt and encode it. And lastly, the robots must be fully scalable. I must be able to give one robot 1,000 processes to look after, or I must be able to put 1,000 robots onto a single process. A good example of where this is applicable, many of you based in Joburg remember about 18 months ago we had those horrendous hailstorms that absolutely devastated most of Joburg. The poor insurance companies were absolutely choking with the number of claims that deluged upon them over the sort of 2 weeks that followed that. It was a major challenge for them. They were holding guys out of HR to do claims processing. It was real carnage. This is no longer the case. Now you have robots looking after your claims process. If you had an event like that as well, all you simply do was go and get a couple more robots, load up the claims process from the library into those robots, and within half an hour, you have quadrupled your claims processing capabilities. Another very simple example, within E&Y, we use robots in different environments. So I have a robot that works for 25 days of the month in HR. So from the 2nd to the 25th, it does everything from onboarding, payroll processing, terminations. But at month end, we have a spike in activity in our finance department. So on the 25th of each month, our robots would automatically reallocate themselves into the finance function and do journal entry processing for 5 days. And on the 2nd, they would roll back into the HR function. So the ability to be able to flex across multiple domains is very, very important. But where robots become really, really powerful is when we combine them with people in the process, where we focus on the people to be able to build relationships, provide a subjective judgment, bring a human element to an environment to make decisions that are not necessarily purely rules-based. Combine that with the processing ability of a robot makes it incredibly powerful. I'll give you a good example of this. A couple of months ago, I was speaking to a CFO of one of the major mining houses, and showing this presentation on robotics, and he was incredibly excited. He said, "James, this is fantastic. We want to use robots across the whole mine, the whole organization, except in finance." I was a little bit puzzled by this, and I sort of said, "Well, why not?" He says, "Well, in my environment, our guys are all CAs. They're making decisions all the time. It's really, really focused, judgmental type stuff." So I asked him if we could perhaps do a little experiment. So the next day we went into one of his finance areas. We had 8 of his team working already, all CAs. And on each of their tables we put a little red flag. And we said, "Guys, during the course of today, every time you make a decision, put the flag up. By the time you finish making the decision, put the flag back down." And we got a little article clerk to sit there with a stopwatch and a piece of paper, and they counted and timed the event. During the course of an 8-hour period, the average decision-making time was a mere 15 minutes. The other 7 3/4 hours was spent either aggregating information to make the decision or processing the result of that decision. Now, you can think about it in that kind of context. Highly paid CAs, supposedly in a highly judgmental assessment, thinking kind of environment, only making decisions for 15 minutes. Not because I don't want to, it's just because I need so much time to be able to move the process along. Now, through the use of robotization, if I could move that 15 minutes to just, say, 2 hours, what a massive impact that would have on the organization as a whole. And that's exactly the scenario where I can start using robots to be able to collect the information quicker, present it to the person to make the decision, acknowledge the decision they've made, and then process the result of the decision so much faster. That is where we start seeing a systemic change to an organization's environment. What I'm doing now is show you a quick little video which summarizes what I've said. What we'll also do at the back end, you'll actually see a robot in action. And when we get to there, I'll kind of talk you through it to be able to see what it does, and it might make it a little bit more real to you. So what you're seeing over here on the right-hand side is the actual robotic software itself working. In this case, it's opening up email from a customer, remittance advice. So it reads the advice, extracts the information from it, it logs onto an ERP system, in this case SAP, and then it captures the information that it took off that attachment. It loads into the various screens that, as you can see, incredibly quickly. In fact, we slowed these screens down a little bit, just so you can see it, because that happens faster than you can see. When it's finished, it types up a custom email back to the customer saying, thank you very much for your business, here is your account balance, and then closes down the process. Now, not a very complex process, but you can imagine the power of doing many, many thousands of these a day, or many types of these processes on an ongoing basis. In that specific scenario, there was a 76% reduction in the time taken to process, 100% error-free. More importantly, is the client sent the email with an attachment. In 39 seconds back, his transaction was processed, and he had a response back to him. He felt like he was working with our system, even though he was not. And that's where the true power of robotics come in. But when we look at RPA, there are generally sort of 3 thematical domains, 3 major areas where we see robots applied. The first one of these is virtual handling. What you've just seen now, the ability to handle and manage a process. It is the most wide and most systemically applicable, and often the first place robots get used in a day-to-day basis. The second one is that of data movement. The ability to use robots to be able to transfer information between different systems. Now, that can come up in different environments. The most obvious one is in data migrations. So we all know in the classic data migration environment, we would take the original system, the source system, the target system, we'd map the tables between the two, and then do a large-scale lift from the one environment into the other. Very complex, and if you get it wrong, it creates a lot of headaches. But whenever we're doing migrations, there's always that element of data that is so pervasive across systems, it's highly risky just to do it by table mappings. Just because if you miss a single table or a single connection in that chain of mapping, the whole house of cards comes falling down. A good example is recently I was doing a migration for a client out on the East Rand in a mining company. And that element of data that we normally would not want to do table to table was their plant projects, because it touched everything from HR, finance, supply chain, IT, the whole area. So those plant projects we wanted to lift out of the old system and put them into the new system. In their case, they had about 600 plant projects, and it took us about manually 2 hours per plant project to be able to load into the new system. So that was looking at about 1,200 man-hours of effort to do that. In about 3 days, we built a robot to do that, and I could do all 600 projects in under 4 hours. So I was able to error-free migrate 600 projects from an old system to a new system in less than 40 hours. That allowed us, obviously, when doing the migration, to be able to do them every mock cycle. I could run the process and delete. I didn't have to worry about delta management over a 3-month period while we were in blackout, while I transferred the data. And on cutover weekend, what happened? Friday night at 12 o'clock, the robot switched itself on, ran the process, and 8 o'clock on Saturday morning, when our cutover teams arrived, all the data was preloaded, ready for us to run the process. Not only that, Sunday afternoon, I got a call from the system implementer saying, James, we seem to have a problem. We picked up a bug during testing. We need to fix it, but we need to roll back the migration. So we rolled it back, they fixed the error, started the process again. What this caused, though, was a small problem in the fact that now we didn't have 2 days to do the migration, because Monday morning, 8 o'clock, was looming. Simple, we add another 10 robots into the process, and we closed that whole process down in 39 minutes. The power of being able to move more robots onto a single environment. Let's do data migrations. Another element in data movement is the ability to move information in a light ETL environment across various systems. Many organizations have to collect data from different systems, and as they aggregate and disseminate it back out again, it's through very complex interfaces or through manual batch uploads. Robotics allows us to be able to log into the front end and move key records on a systemic basis from one system to another. Simple example would be a call center. So somebody would dial into the call center, the operator would type in the person's name, James, and while he's having a conversation dealing with the person, the robot will go to 15 different systems across the organization and extract all the relevant information of that customer and bring it back. While I'm having the conversation, they can say, well, do I prefer an 082 or 083 number, for example? The guy says, 083 is my current cell number. A simple check on the screen, the robot will automatically post that new cell phone number across the 15 systems again. So the ability to be able to aggregate and disseminate that information very quickly without having to build cross-platform interfaces is very useful. The third element of thematic deployment is digital enablement, the ability to decouple a digital front end from a legacy system. In an organization today, the primary reason for upgrading the system is not because the system's business rules per se have changed, but merely because the client or the organization want more complex interfaces and mechanisms of interaction with their customer or stakeholders. With the use of robotics, without having to upgrade your system, you can create digital front ends, be they HTML web pages, whether they're actual digital apps, mobile apps, very, very quickly in a couple of weeks, without having to worry about the complex integration issues with the back-end legacy system. Because the robot sits just behind the app, and as I type in information into the app, the robot physically takes it, posts it into the legacy system, business rules are applied, a response gets brought back to the front end. I, as the end user, get the impression that I'm dealing with an integrated environment when I'm not. The speed of deploying robotics is so useful that should I want to change a field, I don't have to go through UAT and complex coding. I merely tell the robot, here's a new field, and I want you to place it here in the system. 15 minutes later, I now have a new field integrated. If that was a classic development environment, that would have taken us many weeks to take it through a system development life cycle in order to achieve that. Now, when we look at these sort of thematical deployments, obviously it can sit in anywhere in an organization. They can start off simple areas like back office functions is where a lot of the robotic stuff started out. Then it's moved into the more sort of front-end environment. How do I capacitate, increase service delivery, improve customer interactions as a result of deployment of robotics? What we're now seeing is almost the third wave of areas in the organization, which is now going to the support functions, like IT, for example, where you can start using robotics to automate and process various elements of an IT function, from the aggregation of information, for example, mobile management. How do you aggregate information across multiple systems? Data cleansing, the ability to be able to maintain, store, and monitor master data across multiple systems and keep them in check. Robotics plays a key part there. Monitoring user access, system configurations. All of these activities, as everyone in the call will well know, require an aggregation, dissemination, and processing of often a lot of information from disparate systems. This is the sweet spot for robotics. Now, a lot of people look at robotics and their first reaction is, oh, this is very exciting and I can see its application. But what's it going to do to the workforce? Will we systemically now just fire 80% of our staff? What will it do to our society's fabric? And this is where it's quite interesting. And if you take the time to browse the internet, you'll find quite a heated debate around, on the one side, the extreme sort of doomsday sayers saying this will be the end of society, and the guys on the other side saying this, if nothing else, will actually make a more real, more humane society because we'll spend less time processing and more time actually interacting. The jury's out always go. My personal opinion that we'll end up with a far better organization because the deployment of robotics will allow us to be able to process more in a more meaningful manner than we have done historically. There's always a good consideration when looking at robotics to say, what will the human element be? Now, in closing, I'm going to play a short little clip once again, which summarizes some thoughts around what you can do in the human element of robotics. And I'm happy to take any questions that may arise after that. Thank you. I hope that gave you a bit of insight and thoughts around what robotics potentially is, and I'm happy if there are any specific questions or queries to field them, and if not, I'll hand back to the rest of the gang.
We have some questions here from Peter, if I can start with the first one, please.
Sure.
How would the business define the processes?
It's actually quite an important question and a very valid one. So often what happens in an organization is once you understand what robotics can do, the concern is not so how to find the process that can be robotized, it's how do you determine which ones are worth robotizing. In most environments, what will happen is you would do an assessment of your environment, you would target a couple of key areas. Those where there's a large amount of human intervention, which in itself does not add value. Two, where there are potentially very high-risk processes where errors or mistakes are very costly. If you get it wrong, transacting very large transactions, configuring, giving access to different environments, that if you accidentally click on the wrong area, the impact could be quite profound. And then thirdly, those areas where the process is quite variable and I cannot control it very tightly and I want it to be done in a certain way, because a robot doesn't try and find a shortcut. It doesn't try and work around. So you can have a relatively open process that is run in the same basis where you put humans into it. That very quickly learn, oops, if I didn't do this, I can skirt this chip. I can cut this corner, I can miss this step. Those are the three sort of areas that we then look at the process to see which processes get those attributes assigned to them. Then you'll be able to triage it, rank them, assess whether the cost of development and maintaining a robot is less than the benefit we receive from adapting that process. And that ranking mechanism is done before you commence. So what we find in most client scenarios, they would end up bringing up many, many hundreds of processes. We then sit through and say, guys, only the first 50 or 100 actually pass the criteria to justify robotization as opposed to the other way around.
Peter, is that answer sufficient to you?
Yes, that's great. Thank you. I think there are a couple of others. Are you going to run through them then?
I'm going to run through them. So the next question here is, has the recent problem with the IoT botnet led to any more thoughts about security?
Well, in terms of using robotics, I often get the question, does it potentially expose me to greater risk than otherwise not? The benefit of having robots that are deployed in your environment, they are always deployed within your environment, not necessarily exposed. It's not like it sits outside and requires a port to access into your domain. The robot itself sits within your IT environment behind your firewalls. So it doesn't create an increased exposure to attack and penetration per se. And if somebody accessed your environment, it wouldn't be via the bot, it would be through some of the many other exercises. The other area of consideration is if I was able to get access, would I be able to manipulate the robots to do something that is really bad? Well, that risk is relevant, but in 9 times out of 10, when somebody does an attack and penetration, targeting an individual robot to an individual process achieves very little, because we often become aware of that infiltration quite quickly, and the robot doesn't break stuff. Only when the transactions flow through does it become relevant. So as a result, your organization will face a far greater risk in other areas than what somebody could do to the robot per se. Because if I attacked an organization, destroying the databases, stealing the information would be more relevant. None of that is applicable in the robot's environment. So in summary, it doesn't increase your risk, but it certainly doesn't remove it. If anything, your existing infrastructure, protocols around cybersecurity would stay intact and be exactly the same.
Thank you so much. The next question, are there standards emerging for the definition of robot processes?
Yes, there are, and it's often coming from the back of the robot deployments across different environments. So although there are not sort of formalized global standards in play, what you are finding are that there are certain elements around how you go about robotization. All the major vendors, there's about 7 global major vendors, Blue Prism, WorkFusion, Automation Anywhere, UiPath. Those guys generally, if you look at it systemically, follow very similar principles. Most of the major implementers of robotics also follow relatively standard methodological approaches, although their knowledge around how to deploy it and how to extract value will differ. There are standards coming in. What I think is more pertinent, and they haven't there yet, is how will governments, organizations, society govern and standardize these things. So the topic of digital ethics. For an organization, what is the ethical line of robotization that they're willing to go down? Will I be ethically comfortable that I can overnight remove 90% of my staff complement? Just because I'm able to genetically engineer humans doesn't mean that I want to. And I think what's going to happen now in the next sort of couple of years, you'll start seeing various countries, regions, governments, areas actually creating standards around what are the ethical lines and boundaries around the deployment of robotics. You'll also start seeing, for example, in Europe, there has been a white paper released by some of the tax departments saying they actually want to tax robots, because in the deployments of robots, they are losing revenue because resources are now moving out of the corporate environment into the more informal sector, where it's much harder for them to attract PAYE or equivalent personal taxes. Now, there's still some way away for it to become real, but you're already starting to see the thinking happening. So I think the more societal standards will start coming out in the coming years, but from a deployment mechanism, those are relatively quite mature.
Thank you. Our next question here is, how do you see this fitting with DevOps?
Well, that's actually quite a good question. I think what you'll end up finding is that it'll probably be something that sits alongside it and become a part of it. And I've always said robotics is not a silver bullet. It's not something that sits on its own and solves all the problems. So you will find that in many organizations, there's two elements. Ask the question, how could robotics assist in the DevOps space? And then conversely, how does robotics and its associated process center of excellence reside within the DevOps type of domain? Because the way you control, manage, etc., your broader environment would apply just as applicably to robotics. So I think they're more synergistic, and you probably find the application is very common, as opposed to sitting in a dark corner by itself and being very different. It's a kind of loose question, but answer, but it depends very much on which domain of DevOps that you're specifically targeting.
Are there any other questions from anyone in the call? Doesn't seem like it. James, I'm just going to take over the screen again. There we go.
You got it back?
It looks like it. Can everyone see the SMEXA screen?
Yes, that's great.
Fantastic. Any questions from anybody else on the forum? Peter and James, it seems that is it. No further questions for you. Easy round.
Fantastic. Thank you very much, everybody. I appreciate your time.
Yes, thank you very much. That was really interesting, and I hope everybody else has enjoyed it, and the people who haven't been here will be able to enjoy it online afterwards. So thank you very much. It's been a great start to the next 3 days of the SMEXA presentations.
Thank you very much, guys. Good luck.
Thank you, everyone. We hope to join in the next session next week on the 9th. Have a good one.
Muted.